See, basic signals. Up to now we discussed basic signals. There we discussed four signals: step signal, impulse function, and ramp signal and parabolic signals. And according to the electronics point of view, we have another signals standard signals, because electronics representations, everything is explained with voltage and current. Those are available in different formats. Those are comes under standard signals. In this, one standard signal is exponential signal. Exponential signal. The name explains this signal varies exponentially, increases or decreases. Two types of representations are there here with respect to time axis and again with respect to time axis. Now the signal is changing, function is changing with respect to time, exponentially increases. This is exponentially increasing function. Another function is there, exponentially decreases. So exponentially decreasing exactly at a negative time axis, infinity time period, infinity amplitude is there, and if the time axis is increases, amplitude is exponentially decreasing here, exponentially decaying function, and this one exponentially increasing function. Exponentially increasing function representation is e power at, and decreasing function is e power minus at. Then so exponential signals representation, here two types of representations are there. One is e power at and another is e power minus at. This a is positive, exponentially increasing function. A is negative, exponentially decreasing function. This is another standard signal, exponential signal. And one more signal is there, sinusoidal signal. Now here the function is changing, increasing or decreasing exponentially. Now sinusoidal signal is exponentially increases and decreases function. This function is like this with respect to time axis, exponentially increases and decreases, increases, decreases. This type of signal is called sinusoidal signal. Now writing the name of the function is x of t. This function has maximum amplitude. This is maximum amplitude a, and the negative side maximum amplitude is a minus a. So sinusoidally increasing and decreasing in between a and minus a. This is graphical representation. Then the functional representation is x of t is equal to a sin omega t plus or minus pi. This gives the standard functional representation. Here a explains the maximum amplitude. This gives the maximum amplitude of the signal, maximum amplitude positive side and negative side. And this pi explains the phase difference. Phase difference is this gap here from origin to starting of the signal. This gap is called phase difference pi, right? And omega explains the angular frequency. Angular frequency, the standard representation is 2 pi by t. 2 pi is a radians, angle, and t explains the time period of the signal. The time period is time required to complete one cycle. Here one cycle explains the positive and negative cycle. These two are repeated up to infinity. So these two are repeats from minus infinity to plus infinity. Now this part is called repeated signal is called one cycle. Time required to complete one cycle is called time period. So depends on the time period, this omega value changes. So omega is equal to 2 pi by t. This is, we can write like this, 2 pi f. Here f explains the frequency. Frequency general definition is number of cycles per second here. So f is equal to 1 by t. Then the units of this is hertz. Omega units are radians per seconds. So omega is angular frequency, f is frequency. Frequency is 1 by time period and units are hertz. And angular frequency radians per second, angle by time period, so units are radians per second. This explains the omega, and this is phase difference, and this is amplitude. And the sine name explains sinusoidally increasing and decreasing function. And one more representation also there, this is t. T explains the time axis. This is another signal, standard signal, sinusoidal signal. In this signal, now the signal equation is like this here, x of t a sine omega t is there. From this definition, a sine omega t plus or minus pi. Now from this, here I wrote a sine omega t only. That means this phi phase difference is 0 degrees. This gap should be 0 degrees here. If the gap is 0, then the sinusoidal signal is exactly starts from origin. So now the signal graphical representation it starts from origin exactly, because your phase difference is 0. Sinusoidally increasing and decreasing. This function is called a sine omega t. It's also called as pure sine function. Now I am taking this phase difference here. This phase difference is 90 degrees. It is like this. A sine omega t plus 90 degrees here. A sine omega t plus 90 degrees. Now the phase difference is 90 degrees with plus symbol. So this complete signal is shifted left side. Now it started from origin. Now it started from minus 90 onwards. Minus 90 onwards. Sinusoidally increasing and decreasing function. So this phase difference is here. 90 degree phase shift is there. So pi is equal to 90 degrees. Then the equation is a sine omega t plus 90. This function is also called as a cos omega t. So from the mathematical analysis, sine 90 plus theta is cos theta. Amplitude is as it is. This function is pure cos function and this function is pure sine function. These two are comes under sinusoidal signals. This is another standard signal. And the signal standard equation, A explains the maximum amplitude. Sine of omega is angular frequency, and t plus or minus pi is this phase difference. So the standard equation is a sine omega t plus or minus pi. This is a sinusoidal signal.